In this video, we will show you on how to make a real-time chat application using ESP8266. Welcome back to our channel, A3D Learning. In emergency cases like internet breakdown or electricity disruption, this project is very useful. In this architecture, there should be a Wi-Fi router in our home to be able to send message to other people connected in the network. But what if there is no internet connection? That would be a problem. We need to use ESP8266 to create a mesh network. The central nodes are the mesh nodes and the leaf nodes are the access points. Anyone who is near to that access point can send a message, and if any of the central mesh node fail, the leaf node will automatically connect to the other node. The ESP8266 mesh nodes are positioned strategically in a low-rise building like apartment. ESP is a bit cheap, so you can put as many as you can. The following are the hardware components I used in this project. We bought it in AliExpress, which is a way cheaper compared when you buy it locally. This shows how to connect the I2C OLED to the ESP8266 pins. I2C has 4 pins. The OLED is for debugging purposes. Arduino for the firmware coding and uploading of sketch to ESP. Visual Studio to design the client web application. Many libraries are readily available in the GitHub. These are the libraries I used in the project. Check them out. I have 2 views for the interface, login page and chat page. Just tap your name and you're good to go. Click ESP8266 Sketch Data Upload to upload the HTML or JavaScript files. Make sure to get the correct board, upload speed, and the COM port number. Since the web application is hosted in the ESP server, I need to create a mobile application that directs me to the server IP address instead of typing it in my browser. There's a Cordova plugin called Wi-Fi Wizard 2 which gets the IP address of the network you're connected to. I have a separate video on how to run your hosted web app in Cordova. This is the mobile app HTML file and this is the JavaScript file. When you click the connect button, it will redirect you to the IP address of the network. It will check first if it is AP8266 SSID. If not, then it will display an error. Else, it will open the web chat application. We need to generate APK files so we can install it in our Android phone. Now that we have the APK, we can install it in our phone. So let's try to open it. Since I am not connected to AP8266, it shows an error. So let's try again to connect if it works. I used breadboard in the debugging stage. Now we can connect the OLED to the ESP pins using jumper wires. Check the pin connection as it will damage your ESP or OLED. By the way, we need first to connect the ESP to the PC USB port before we can upload the sketch. Plug it and upload the sketch. Each phone is connected to different access points for debugging purposes only. I purposely used different AP name to know that the access point is really working. The more mesh nodes, the better the coverage. Open the mobile phone setting and check the Wi-Fi connection. Open the web app in the browser or in the Android app we have just installed to start chatting. Client 1 will send message to the network. Client 2 and 3 received the message. Now, client 2 will send message. Client 1 and 3 received it. Lastly, client 3 will send message and client 1 and 2 were able to receive it. I asked my husband to help me. He will go downstairs, I am at the 12th floor and he is at the 11th floor. The left side of the video is him at the 11th floor and at the right side video is me at the 12th floor. As you can see, the chat is real time because we are using WebSocket protocol. The coverage range is only around 15 to 20 meters, which is not bad at all. Take note, we are only using Wi-Fi for this project. So, if you want to cover the entire building, we need to add more ESP nodes or use LoRa instead. This is for a future plan. Thank you for watching. Please subscribe and hit the like button if you like the video. If you have comments or suggestions, please feel free to comment down below.